We now discuss the solution of a problem that appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The problem is related to the solution of an initial value problem. This question is from the section Differential Equations. The given question is, let y is equal to y of x be the solution of the differential equation 1 minus x square dy is equal to, in brackets, xy plus x cube plus 2 multiplied by under the square root of 1 minus x square, bracket close, dx, where minus 1 less than x less than 1 and y at 0 is equal to 0. If the integral minus 1 by 2 to plus 1 by 2 of under the square root of 1 minus x square into y of x dx is equal to k, then k inverse is equal to. So we are given y is equal to y of x is the solution of this differential equation with this initial condition. And if y of x is the solution, that solution you take and put that solution in this integral. Integral minus 1 by 2 to plus 1 by 2 another square root of 1 minus x square into that solution y of x dx. And if that is equal to k, required to find the value of k inverse. That's our given question. We now discuss the solution of the problem in detail. We have the given initial value problem. What is an initial value problem? A differential equation equipped with an initial condition is called an initial value problem. Here we have, this is the differential equation and y of 0 is equal to 0 is the initial condition. Agreed. Now this differential equation can be written as 1 minus x square into dy by dx is equal to xy plus x cube plus 2 multiplied by under the square root of 1 minus x square. This will imply dividing throughout by 1 minus x square, we will get dy by dx minus this xy is brought to the left hand side minus x by 1 minus x square multiplied by y is equal to x cube plus 2 by 1 minus x square into under the square root of 1 minus x square. After cancellation, root of 1 minus x square will sit down in the denominator. Agreed. That is the differential equation. Agreed. And how this is looking like? This is of the form dy by dx plus p of x, a function of x into y, is equal to q of x. So what is this? It is a well-known first order linear differential equation. It is an linear ordinary differential equation in y. Right. To solve such a differential equation, we take its integrating factor. The integrating factor is given by e power integral p of x dx. Then we write down its general solution and it is given by y into integrating factor is equal to integral of q of x into integrating factor, integrate with respect to x plus c, where c is an arbitrary constant, it's a constant of integration. Agreed. So let's get into our question. In our question, p of x is minus x by 1 minus x square, q of x is x cube plus 2 by under the square root of 1 minus x square. Now the integrating factor is e power integral px dx is equal to e power integral minus x by 1 minus x square dx. So we will integrate this one. To integrate this one, put 1 minus x square is equal to t. Differentiate minus 2x dx is equal to dt and minus x dx is dt by 2. Right. So get into the integral minus x by 1 minus x square dx is equal to minus x dx is dt by 2. This is dt by 2. And 1 by 1 minus x square is 1 by t. So this is 1 by 2 into integral of 1 by t, that is ln t. That is ln t. So that is the integral, and the t you put back 1 minus x square and 1 by 2 you take care. That is ln of root t and the root of t is 1 minus x square. So ln of root of 1 minus x square is the integral of minus x by 1 minus x square dx. Now come back to our mainstream. So put it here. So this is e power integral ln of root of 1 minus x square, and that will be equal to under the square root of 1 minus x square. Agreed. So we got the integrating factor, and how the general solution is given by y into integrating factor is equal to integral of the right hand side function q of x into integrating factor with respect to x plus c. So the general solution is given by y into integrating factor under the square root of 1 minus x square is equal to integral of q of x. Q of x is the x cube plus 2 by under the square root of 1 minus x square into integrating factor under the square root of 1 minus x square dx plus c. We continue in the next slide. The general solution is this one, and the square root of 1 by 1 minus x square, which is appearing in the denominator as well as in the numerator, cancel. Then you will get the integral of x cube plus 2 dx plus c. Integral of x cube is x to the power of 4 by 4. Integral of 2 dx is 2x plus c. So it is x to the power of 4 by 4. Yeah, integral of x cube is x to the power of 4 by 4. Integral of 2 with respect to x is 2x plus c. So therefore the GS is given by y into under the square root of 1 minus x square is equal to x to the power of 4 by 4 plus 2x plus c. To evaluate c, we are given the initial condition. So given y at 0 is equal to 0. That means y is 0 when x is 0. So put y is equal to 0 and put y is equal to 0 and x is equal to 0. This is not y is 0. This is x is equal to 0. Put y is equal to 0 and x is equal to 0 in the above, then we'll get c is equal to 0. Agreed. Then the particular solution is given by y is a function of x, y of x multiplied by under the square root of 1 minus x square is equal to x to the power of 4 by 4 plus 2x. C is 0. We have evaluated. This is the particular solution. Why this is called a particular solution? It is a solution obtained for a particular choice of x and y. So for a x and y, there is a y at 0. That is the value of y is equal to 0 when x is equal to 0. Then c is 0. Thus we get a particular solution. Agreed. Now what is that we want to find? We are given k value. So we are given k is equal to integral minus 1 by 2 to plus 1 by 2 square root of 1 minus x square into y of x dx. And look the above. The above one is root of 1 minus x square into yx is x to the power of 4 by 4 plus 2x. So in the place of this one, you write x to the power of 4 by 4 plus 2x. That is equal to integral minus 1 by 2 to plus 1 by 2 x to the power of 4 by 4 plus 2x dx. Separate the integral. Integral of the sum is equal to sum of their integrals. So 1 by 4 integral minus 1 by 2 to plus 1 by 2 x to the power of 4 dx plus 2 times integral x dx with the appropriate limits. Now look at here. Look at here. X to the power of 4 is an even function. It is minus a to plus a. It's an even function. And this will be 2 times 0 to 1 by 2 x to the power of 4 dx. And look at x. X is an odd function. X is an odd function. This will be equal to minus 1 by 2 to plus 1 by 2. An odd function with respect to x is 0. So that is the rule what we have studied in our integration classes. Agreed. Now this will be equal to 1 by 4 2 times integral 0 to 1 by 2 x power 4 dx. So because it is an even function, because it is an odd function, it is 0. So 1 by 4 into 2 is 1 by 2 into integral of x to the power of 4 with respect to x is x to the power of 5 by 5, and it is a definite integral to be evaluated between the limits x is equal to 0 to 1 by 2. So this will be equal to 1 by 2 into 5. Yes, this 5 will be 1 by 2 into 5. X to the power of 5, when x is equal to 1 by 2, 1 by 2 to the power of 5. When x is equal to 0, it is 0. So 1 by 2 to the power of 4, 5 is 1 by 32 into 1 by 10. That is equal to 1 by 320. That is the value of k, but we want k inverse, and that is equal to 320. That is the required answer to this question. So that is the detailed discussion of the solution of a given initial value problem, and the question is from the differential equations. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.